Volumetric Scanner for external corrosion measurement. TGS engineers associated in a team with scientists and engineers from the Balseiro Institute for Nuclear Physics have designed an automated system for measuring and assessing external corrosion in pipes under operation. After having examined different measurement alternatives, a bidimensional high-resolution optical sensor technique method was selected. The equipment was fully designed by Argentinian scientists and is composed of the following parts. Optical laser sensor. This sensor is mounted on a linear guide rail along which it can move at a speed of 1,200 millimeters per second and has a depth resolution of 0.002 of a millimeter, which allows recording of up to 1,200 points per second. Support frame. The linear guide rail is mounted on a frame constructed of aluminium, suitable for moving over a 1,000 millimeters by 80 degrees scanning surface. Curved guide rail. Motion in the circumferential direction is provided by means of a curved rack guide equipped with a stepping motor operated rack and designed so as to allow measuring a line every 3 millimeters in the scanned area and 1 point every millimeter in the axial direction. The assembly is designed for making one measurement every 2.85 square millimeters, thus reaching a total of 185,000 points in the scanned area. The total scanning time does not exceed 5 minutes. Data transmission. Data is transmitted to a control PC by a Bluetooth system. Control PC. This personal computer allows remote operation of the equipment, monitoring the progress of the online scanning and conducting a fully automatic evaluation of the defects, as a result of which the appropriate report is issued in Excel format. As soon as the design stage was completed, a critical evaluation of the behavior of the selected individual parts and the equipment assembly constructed in the field was conducted. The equipment functionality under actual operating conditions was checked and results were satisfactory. The equipment can be manually carried by 2 people. It was fastened to the pipe spool by using tape and tension members. TGS has designed a vehicle suitable for transporting and remotely operating the volumetric scanner, as well as for online defect assessment. Our own PitExplorer software allows measuring and analyzing the defects found in a user-friendly environment. Various functionalities can be seen on the screen. On the left side, an interactive tree is displayed that allows proceeding to the different stages of the work, such as measurement, surface correction, and analysis. A color bar allows identifying the depth of the corrosion-related defects. For a better viewing, the defects are projected in the axial and longitudinal direction. Considering that the pipes are normally subject to deformation as a result of the manufacturing process itself, the surface should be corrected in order to obtain a reliable reference. This is obtained by identifying with the cursor the defect-free surface. By clicking with the mouse, the tone of such surface will turn gray. As soon as correction is completed, the deformation-free surface is obtained. A reliable reference is now available for analysis thereof. The coordinates X, Y, and Z of the defect can be seen on the upper right corner. After surface correction, the analysis stage is activated in the tree. Then, piping data such as the wall thickness, outside diameter, specified minimum yield strength, maximum allowable operation pressure, and safety factor is entered. The rule of interaction between the defects. Rolling the mouse wheel will zoom the defects, and a cross-sectional view thereof can be seen at the ends of the screen. As soon as the analysis stage is activated, the software will automatically identify the clusters and color them in different tones. The software can plot the cluster limits, the deepest point, and the river bottom profile. The results of the analysis are displayed in the lower portion of the screen. The following data is obtained for each cluster: axial length, circumferential width, maximum depth, burst pressure, maximum safe working pressure, effective length, safety factor. In addition, the software shows us whether the need exists for repairing the defect. Any defects found having a length exceeding the scanning length are assessed by moving the scanner to completely cover the defect. The software allows overlapping measurements and combine them as many times as required. The images from every measurement are taken from the tree and the overlapping point is identified manually. As soon as overlapping is obtained, correction and analysis are conducted. The report on the defects assessed is automatically obtained after entering the pipeline data. The defect assessment report is based on an Excel template and designated as Pipeline Damage Report, which allows obtaining printed copies of the images of the defect examined. The construction of the volumetric scanner for external corrosion measuring in pipes under operation allowed TGS to significantly reduce the time required for the defect evaluation work, with a precision 10 times greater than that obtained manually and a very low probability of human error.